Right, so an important detail about all of this is what is the policy outputting and sending to the robot in order to make it do an action. So the robot has 6 motors, and they're all revolute joints, so they rotate. So you can consider their positions as like angles. So like say a motor has a position of 45 degrees, and I want it to go to 50 degrees, then I need it to go up by plus 5 degrees. And so this is like a relative angular target. Relative, right? And this is what my policy is going to output. Right? Within my policy, I've got a neural network actually that outputs values in -1 to 1. But maybe I want, plus 5. So how do I get that from -1 to 1? Maybe I scale this by some amount. Maybe I scale this by 10. So whatever comes out of the neural network, I multiply by 10, and it's in the range -10 to 10. And then plus 5 is within that range, and so it will be able to produce the action that I've described here. The question is, how much should that scaling factor be? And this is important because we want it to be enough for the task to be able to be achieved, but the other thing is we don't want the robot to break itself, especially in the early stages of learning where the policy or the agent is exploring and doing crazy erratic movements, which might whack the robot against a table or other objects, or vibrate the robot too much and overheat the motors, etc. So what we're going to do then is to check what we need for those limits is we're going to run the teleoperation script, and I'm running at 20 frames per second, or the control loop is 20 hertz because that's what I'm going to be using in my actual training loop. So first of all, I'll demonstrate to you, like, if I move my left arm, which is on the leader arm, very quickly right now, the follower arm will follow as fast as it can, and this sort of movement is much faster than we really need. We just really need a nice gentle push of the cube from the right to the left, and then from the left to the right. So let's figure out what is the maximum, kind of relative angular target that I need to achieve the task. So I'm going to go into my teleop script, and I have this place here where the robot does a teleop step and reports on the action magnitude, and then this is the relative action, which I calculate from the absolute action, the absolute positional target, minus the current state of the follower arm. So I can print that relative action, but actually better, I can initialize a maximum relative action like this, and I can update that accordingly here. So maximum relative action equals the maximum of the current relative action, the absolute value of the current relative action, because that's what I care about, the absolute value, and the maximum relative action. And I'm going to print the maximum relative action. And what I'm going to do now is I'm going to run this script again, and I'm going to essentially do the task that I want the agent to do at the kind of pace that I want the agent to do it at. Vary it up a bit, move the cube forward, pull it back in bounds, move the cube back, push it back in bounds. Just do all the sorts of things that I want the agent to do. Then I'm going to quit, and I'm going to see what is the number that I've got here. What are the 6 numbers that I have here? And this is the maximum I needed in terms of relative angular targets and absolute value for all of the motors. Now, I've done this experiment many times before as I was setting things up, and I came up with these numbers instead, which look similar but they're not exactly the same. And these are in my robot configuration file. And so I can actually uncomment this, and I can run this again. And even if I move really quickly with my arm, and I'm moving all over the place with my leader arm right now, you can see that the follower arm's movement speed is kind of capped. And this is what I want. I can still perform the task as needed. I have no problems performing the task, but I'm less likely to have issues, especially in the early stages of training when the agent is exploring. Now, another detail, just like implementation detail here, unfortunately you have to take this and copy paste it into your policy configuration file where you're overriding the dataset statistics, and you're going to set the minimum action to be the negative of that and the maximum action to be the positive of that, that vector there. And what that's going to do is when your neural network outputs a vector of 6 values in -1 to 1, is it's going to scale them. So it's going to take the first value multiplied by 5, the second value multiplied by 8, and so on, to get it within the range that you need for sending to the robot.